In today's video, we're going to look at section 3.1, linear inequalities. This is going to lead us into some linear programming. So first thing I want to look at is some properties of inequalities and make sure that we are all on the same page and all know what the different inequalities mean. So if you ever see for two values A and B, this is A is strictly less than B, so that A and B are two distinct values and A is strictly less than B. It cannot equal it, it has to be strictly less than. So for example, you could say that -2 was less than 1, would be an example. You can also have a strictly greater inequality where again A and B cannot be equal, A is strictly greater than B. So you could say something like 3 is greater than 1. Then we have the inequalities where it could be less than or equal to or greater than or equal to. So you could have A is less than or equal to B and A is greater than or equal to B. So for example here, we could still say that -2 is less than or equal to 1. We can also say that -2 is less than or equal to -2. Okay, that is also true. It is equal to it, but we're here saying less than or equal to. So be aware of that, the difference between a strict inequality and a not strict inequality. And of course we can do the same thing with greater than or equal to. Whenever you have any one of these inequalities, you can add or subtract the same number from both sides, exactly the same as you would do with an equation when you have an equals. So if I had, for example, A is strictly less than B, okay, I could add some value C to both sides of my inequality. It doesn't matter if C is positive or negative, we can add it to both sides and that inequality still remains true. Same is true if you subtract a value from both sides. As long as you do that to both sides of the inequality, it is still satisfied. Again, it doesn't matter if C is positive or negative. As long as you do it to both sides, then the inequality will always hold true. So this holds for all four of our inequalities: less than, greater than, less than or equal to, and greater than or equal to. The thing that we have to be aware of is when you have some multiplication. So if you multiply by a number on both sides, so again, we'll start with A is less than B. If I multiply by a value C, again, we're going to do it on both sides. If C is positive, so C is greater than or equal to 0, then this is true. Okay, you do not have to do anything to the inequality as long as you do it to both sides and that value C that you are multiplying by is positive, then this is true. The problem that you have is if C is negative, so if C is less than 0. If that is the case, then we have to actually reverse our inequality. So if you multiply both sides by a positive number, inequality remains true. If you multiply both sides of the inequality by a negative number, then we have to switch the inequality around. That holds for if you have less than, you would switch it to greater than. If you had greater than, you would switch it to less than. And of course the same holds if you've got less than or equal to or greater than or equal to. So make sure if you ever multiply both sides by a negative number that you always switch the inequality. An example of this would be to say that 2 is less than 4. Okay, that's true. If I multiply both sides by -3, so 2 multiplied by -3 and 4 multiplied by -3, I would have -6 on the left and -12 on the right. -6 is greater than -12. So I switch my inequality around. So make sure that you remember that whenever you do any kind of manipulation involving multiplication of negative numbers for inequalities. So let's say I've got -4x plus 5 is greater than or equal to -7. Okay. And the question is solve for x. So you have this inequality with a variable in it that you need to solve for. How do we do that? You treat this exactly like a normal equation, just be aware that sometimes we may have to multiply or divide by a negative number, which means that we will then have to switch our inequality around. Okay, so let's do that in this case. In order to solve this, if this were an equals rather than a greater than or equal to, first thing you would do is subtract 5 from both sides. That will give you your variable on one side and all the other constants on the other. So that would give me -4x is greater than or equal to, subtracting 5 from both sides would give me -12. Okay. Then I have to divide through by -4 or multiply by -1/4. It completely depends on what you want to do. It will give you the same result either way. So if I either multiply by -1/4 on both sides, or I divide by -4, you're going to get the same result. So if I do that, then the negatives will cancel out and the 4s would cancel out on that side and the negatives would cancel out here. But I have to switch my inequality around because I have multiplied through by a negative number. Same goes for if you divide through by a negative number, you have to switch your inequality around. So that leaves me with x is less than or equal to 12 divided by 4 is 3. Okay. So whenever you get a problem like this, make sure that you go ahead and switch that inequality around if you are multiplying or dividing by a negative number. Now we have to look at any kind of inequality that involves two variables, two unknowns. When we do this, you are dealing with equations and you are dealing with functions, things that we would draw as a line or as a plane, okay? So for example, let's take 4x minus 7y is greater than or equal to 14. Okay, so we have this inequality, this time in two unknowns. The thing that I want you to do, whenever you get an inequality of this form, just because of how we are going to be conducting our problems whenever we do any of these, I want you to put this in slope-intercept form. Okay. You have an equation in two unknowns. You can't solve this. We don't have two equations in two unknowns, so it's not possible to solve this. But whenever they give you this type of problem, what they're going to ask you to do first of all is to put it into slope-intercept form. So you're still going to use that inequality, you're just going to put it into slope-intercept form. So if we do that, we always put the y on the left and everything else goes on the right. So that would leave me with negative 7y is greater than or equal to negative 4x plus 14. So all I have done is I've put my x and my constant on the right and my y on the left. Now I've still got a negative 7 as a coefficient of y, so I need to divide through by that, but I'm dividing by a negative, so I need to switch my inequality around when I do that. So that would leave me with y is less than or equal to, the negatives would cancel out here, I would get 4 over 7x minus 2. Okay. So rather than having this equation in two unknowns, it's in this general form, I now have it in slope-intercept form. What we are actually going to do is show what this looks like on the Cartesian coordinate plane. So before, whenever we had something that was in slope-intercept form, you could draw that as a line. You would find your x and y intercepts, you would draw a line. Now we have this inequality. This inequality actually represents a plane. You now don't just have a line, you have a plane. You have not only the points that lie on the line y is equal to 4 over 7x minus 2, because remember we have a less than or equal to here. You don't only have the points that lie on the line, you also have any points that satisfy that y is less than 4 over 7x minus 2. So this actually represents a plane, and we're going to look at how we would draw that on our Cartesian xy plane. So we're going to look at how we can graph these particular inequalities. So I've taken an example here where y is less than or equal to 2x plus 1. This is already in our slope-intercept form. So I've started with this example as we can basically skip a step here. But whenever you go to graph something, we know that it's a lot easier to graph it when it's in slope-intercept form. So whenever you get one of these problems where you have this inequality that's in two variables that they ask you to graph, please always put it in slope-intercept form first. So that's already done here. When you graph these, the first thing to do is actually to graph the line as though it were an equality. So graph it as though it was a simple straight line equation. So you're going to do that. In order to do that, many ways you can do it. I would just recommend finding the two intercepts, the x and the y intercepts, and then joining them up and extending the line. So I found the x-intercept and the y-intercept for this particular line of y is equal to 2x plus 1. That gives us the line. This inequality will include that line because we have, if we look here, we have less than or equal to. So the equal to part is included in this inequality. So it is actually going to include that line. Next, you need to now look at where is y less than 2x plus 1. So let's look at the other part of that inequality. We've looked at the equals part, let's look at the less than part. What I would always recommend doing is to look at whether the origin 0, 0 satisfies your inequality. If it does satisfy the inequality, then you know that everything to that side of the line satisfies the inequality. If the origin does not satisfy the inequality, then it's everything to the other side of the inequality that satisfies it. Everything to the other side of that line. So whenever you do this, always go ahead, find the line and plot the line on an XY plane. Then once you've plotted the line, look at whichever side the origin falls on that line. Look at the origin and plug in 0, 0 into your inequality. If it satisfies the inequality, then you know that everything to that side of the line that the origin is on will satisfy this inequality. If the origin does not satisfy the inequality, then it's everything to the other side of the line that satisfies it. So in this case, if I plug in 0, 0 into my inequality, I would get 0 is less than or equal to 0 plus 1, which means 0 is less than or equal to 1. That's true. So I know that the origin is on the correct side of my line in order to satisfy the inequality. Now we would eliminate everything that is on the other side of the line to the origin in this case, because the origin is on the correct side of the line. The origin does satisfy the inequality, so we're going to eliminate everything that's on the other side of the line. So if you go ahead and plot this, I've just done a very simple sketch. I've put in my two intercepts and I've drawn the line. I have then seen from what I've just done that the origin here satisfies my inequality, which means that it is on the correct side of the line, and everything that you see basically here on my graph satisfies that inequality. So I know I'm fine there. It's everything on the other side of the line that does not satisfy it. So I've scratched out everything on the other side of the line, and everything that is in this clear plane that we see basically below the line will satisfy my inequality. And we are also including the line in satisfying the inequality because it is a less than or equal to. So anything that has that equality where it equals basically on the line will also satisfy it. Okay. So whenever you get one of these problems, always follow these steps. Put it into slope-intercept form first. Once you've got that graph in slope-intercept form, that formula is in slope-intercept form, you then go ahead and you draw the line, exactly like we have done here. Once you've plotted that line, you then go ahead, and I would recommend, you can use any point you want, but to me 0, 0 is the easiest point that I can plug in here. You go ahead and plug in that 0, 0, that origin. If the origin satisfies the inequality, like it does here, then we know that the origin is on the correct side of the line to satisfy the inequality, which means it is on the side that satisfies the inequality. Everything on that side of the line will satisfy the inequality. Everything on the other side will not satisfy the inequality in this case. If the origin did not satisfy the inequality, then you're going to scratch out everything that's on the side of the line of the origin. Okay. Then that's exactly what you do for your next step. You scratch out everything that does not satisfy the inequality. Anything that is left as a blank space will satisfy the inequality. And in this case, because we have a less than or equal to, because of that equals, everything on the line also satisfies the inequality. Okay. We'll look at another example here. This time I've got 4x minus 5y is greater than or equal to 25. And we've got to plot this. So this time, I have to put my line into slope-intercept form. At the moment, it's in general form. I've got to put this into slope-intercept form in order to graph it. It's way easier to do it that way. So I put my line into slope-intercept form, and this is the line that I get. Y is less than or equal to 4 over 5x minus 5. Once I've got that, I can then go ahead and I can plot my line of y is equal to 4 over 5x minus 5. I plot that just by finding my two intercepts, join the intercepts up, extend the line. Once I've done that, I then need to look at the origin. Does the origin satisfy the inequality? So let's look at that in this case. In this case, I would get 0 is less than or equal to 0 minus 5, which gives me 0 is less than or equal to negative 5. That is not true. So because 0 is not less than or equal to negative 5, it tells me that the origin is on the wrong side of the line. So everything on the other side of the line to the origin will satisfy the inequality. Anything on the same side of the line as the origin does not satisfy the inequality. And that is exactly what I have done here, okay? So I have drawn my line after I found my intercepts from my slope-intercept form. I've drawn my line out. I have then found that the origin is on the wrong side of the line. The origin does not satisfy the inequality, so everything on that side of the line needs to be scratched out because it doesn't satisfy the inequality. So here we see that everything below this line would satisfy the inequality, and also including the line because it, in this case, we had a less than or equal to. So anything that equals anything that's on the line will also satisfy this inequality. If you ever get a strict inequality, so it's either strictly less than or strictly greater than, it will not include the line that you draw. So you go ahead and do exactly the same where you go ahead and find the line, etc., etc. But at the end, you will not include the line in what satisfies the inequality. So it will either be everything above or below the line, but not including the line if you have a strict inequality. A lot of the time they will do this by actually drawing out a dotted line instead of a solid line like I've done here. So instead of this red solid line, if it was a strict inequality that did not include the line, they tend to draw it as a dotted line or just some other broken line is how they tend to draw it. The other type of problem you might get and this is where we're going to be heading with our linear programming problems, is where you have to graph something called a feasible region. Okay? So instead of just graphing one particular inequality, you have to graph multiple inequalities at the same time. So what I've done here is I've said to graph, it's called the feasible region. It's the region that satisfies all of the inequalities at the same time. So whenever you see feasible region, most of the time you're going to be graphing multiple inequalities. It is just the region that satisfies whatever inequalities you have in your system. So here we're going to be graphing the feasible region for the system of inequalities of these three inequalities. What these are basically exactly what we have just done, but I've put them all together. And again, we're only looking for a sketch here. You can plot out the points that give you the intercepts, etc., etc., and they may ask you for that, but for right now, I'm just drawing a sketch of these. So I've got to put all three of these onto one graph. And that is what I have done here. So I've graphed y is equal to 2x plus 1. I've graphed y is equal to 4 over 5x minus 5. I need to put that back in. And then x has to be greater than or equal to 0. So I'm also giving you the right-hand side of the plane on this particular xy plane. Okay. Anything that doesn't satisfy an inequality has been scratched out. So you have to scratch out multiple things here. We scratched out above the line of y is equal to 2x plus 1. We scratch out above the line of y is equal to 4 over 5x minus 5. And you can go ahead and see that that is exactly what we had from our previous graph. So I had that for that one and that for the other one. And I've put it all together onto one plane. Okay. And we also have to scratch out anything where x is less than 0. So anything on the left of this plane also needs to be scratched out. So all we actually end up with is this region down here, including this line and also the bottom part of my y-axis. And then it would be this whole region that would be here, including those lines. So anything in blue there would be included, but we always leave it as a blank space. Okay, so it would be everything on that line of y is equal to 4 over 5x minus 5 up to the y-axis, and then down the y-axis, and everything to the right of that would be included and satisfies all three of these inequalities. So whenever you get this and they ask you to graph the feasible region, you've got to look at the region for each one. So look at exactly what we just did, solve each one of the three individually, and then combine it all together and put them on the same graph and see where that region overlaps. So where are they all satisfied at the same time?